Good day everyone, my name is Stephanie Angel B. Paris and today I'm going to discuss the normal flora of human body. So what is normal flora? It states here that microorganisms are found in everywhere. Some species of microorganisms are found in the normal healthy individual in which are non-pathogenic, or we can say that they are not able to produce disease. It is not able to eliminate them from the skin intestine. Antibiotics are capable of drastically reducing their number to a minimum. The normal flora is acquired after birth and changes continuously throughout the life. So there are two types of normal flora, the residential flora and transient flora. So let me discuss first the residential flora. Members of the flora that are constantly present and on the body that cannot be removed permanently. This prevents the permanent colonization of the body by other organisms. Also, flora which are regularly present in a given area at a given age and when disturbed, it promptly reestablishes itself is known as resident flora. For example, E. coli in the intestine of man. E. coli is also known as Escherichia coli, is a gram-negative, facultative anaerobic, rod-shaped, coliform bacterium of the genus that is commonly found in the lower intestine of warm-blooded organisms. So the second type of flora is the transient flora. It is derived from the environment, does not produce disease, and does not establish itself permanently on the surface. Also, members of the transient flora are generally of a little significance so long as the normal resident flora remains intact. If the resident flora is disturbed, transient microorganisms may colonize, proliferate, and produce disease. For example, pneumococcus may be found in the nasopharynx of humans from time to time. There are beneficial effects of normal flora. The first one is the normal flora can synthesize and excrete vitamins in excess of their own needs, which can be absorbed as nutrients by their host. For example, in humans, enteric bacteria secrete vitamin K and vitamin B12, and lactic acid bacteria produce certain B vitamins. Germ-free animals may be deficient in vitamin K to the extent that is necessary to supplement their diets. And also, normal flora can stimulate the production of natural antibodies. Since the normal flora behave as antigens in an animal, they induce an immunological response, in particular, an antibody-mediated immune response. Low levels of antibodies produced against components of the normal flora are known to cross-react with certain related pathogens and thereby prevent infection or invasion. Antibodies produced against antigenic components of the normal flora are sometimes referred to as natural antibodies, and such antibodies are lacking in germ-free animals. And normal flora may antagonize other bacteria through the production of substances which inhibit or kill non-indigenous species. The intestinal bacteria produce a variety of substances ranging from relatively non-specific fatty acids and peroxides to highly specific bactericins which inhibit or kill other bacteria. If there is a beneficial, there is a harmful effects of normal flora too. First is the induction of low-grade toxemia. It states here that minute amounts of bacterial toxins such as endotoxin may be found in the circulation. Of course, it is these small amounts of bacterial antigen that stimulate the formation of natural antibodies. And for further, the normal flora may be agents of disease. Members of the normal flora may cause indigenous disease if they reach a site or tissue where they cannot be restricted or tolerated by the host defenses. Many of the normal flora are potential pathogens, and if they gain access to a compromised tissue from which they can invade, disease may result or exist. Another harmful is the transfer to susceptible hosts. Some pathogens of humans that are members of the normal flora may also rely on their host for transfer to other individuals where they can produce disease. This includes the pathogens that colonize the upper respiratory tract, such as Neisseria meningitidis. So let's proceed to the normal flora of our skin. Skin is constantly exposed to and is in contact with the environment. The skin is particularly apt to contain transient microorganisms. Most bacteria on the skin are sequestered in sweat glands. The skin microbes found the most superficial layers of the epidermis in the upper parts of the hair follicles are gram-positive cocci and corynebacterial such as propionibacterium. These are generally non-pathogenic and considered to be commensal, although mutualistic and parasitic rules have been assigned to them. Staphylococcus aureus is found on the face and hands in individuals who are nasal carriers. This is because the face and hands are likely to become inoculated with the bacteria on the nasal membranes. Such individuals may auto-inoculate themselves with the pathogen or spread it to other individuals or woods. So let's proceed to the normal flora of the conjunctiva. It is relatively free from organisms due to the flushing actions of tears. For examples, Dipteroids, Staphylococcus, Dermides. The conjunctival flora is normally held in check by the flow of tears in which contains antibacterial lysosome. So let's proceed to the normal flora of the respiratory tract. There are upper respiratory tract and lower respiratory tract. The upper respiratory tract is the primary source of lung microbiome. In healthy individuals, the lung microbiome seems to largely consist of transient microorganisms and its composition is determined by the balance between microbial immigration and elimination. While lower respiratory tract, such as trachea, bronchi, and pulmonary tissues, is virtually free of microorganisms, mainly because of the efficient cleansing action of the ciliated epithelium which lines the tract. Any bacteria reaching the lower respiratory tract are swept upward by the action of the mucociliary blanket that lines the bronchi, to be removed subsequently by coughing, sneezing, swallowing, etc. If the respiratory tract epithelium becomes damaged, as in bronchitis or viral pneumonia, the individual may become susceptible to infection by pathogens such as H. influenzae or S. pneumoniae, descending from the nasopharynx. And we have the normal flora of the orogenital tract. Urine is normally sterile, and since the urinary tract is flushed with urine every few hours, microorganisms have problems gaining access and becoming established. The flora of the anterior urethra, as indicated principally by urine cultures, suggests that the area may be inhabited by a relatively consistent normal flora consisting of Staphylococcus epidermides, Enterococcus faecalis, and some alpha hemolytic streptococci. Their numbers are not plentiful, however. In addition, some enteric bacteria such as E. coli or Brutus and Corynebacteria, which are probably contaminants from the skin, vulva, or rectum, may occasionally be found on the anterior urethra. Let's proceed to the normal flora of the oral cavity. The presence of nutrients, epithelial debris, and secretions makes the mouth a favorable habitat for a great variety of bacteria. Oral bacteria include Streptococci, Lactobacilli, Staphylococci, and Corynebacteria with a great number of anaerobes, especially bacteroids. The mouth presents a succession of different ecological situations with age, and this corresponds with changes in the composition of the normal flora. At birth, the oral cavity is composed solely of the soft tissues of the lips, cheeks, tongue, and palate, which are kept moist by the secretions of the salivary glands. At birth, the oral cavity is sterile but rapidly becomes colonized from the environment, particularly from the mother on the first feeding. So let's proceed to the normal flora of the gastrointestinal tract. The bacterial flora of the gastrointestinal, the tract of animals, has been studied more extensively than that of any other site. The composition differs between various animals species and within an animal species. In humans, there are differences in the composition of the flora which are influenced by age, diet, cultural conditions, and the use of antibiotics. The latter greatly perturbs the composition of the intestinal flora. So let me enlighten you about the symbiosis. Organisms interact with each other in a variety of ways. This interaction can be cooperative, antagonistic, defensive, reciprocal, harmful, communal, opportunistic, beneficial, or neutral. Symbiosis encapsulates the relationships that different species of organisms have with each other, the good, the bad, and the ugly. This interaction typically fall into one of three categories: the mutualism, parasitism, and commensalism. When we talk about the mutualism, it is a mutualism relationship is one in which organisms benefit from interacting with each other. They cooperate with each other to achieve a desired outcome that will be beneficial to both of them. While parasitism is a kind of relationship in which one organism benefits and the other one is harmed. And commensalism is one in which one organism benefits and the other organism is unaffected, meaning it is neither harmed or benefited. That would be all. Thank you for listening. God bless and keep safe.